some of you used the investigation activity to do some observation and you came up with the correct answer actually. However, that is working for you because the determinant of this matrix is 1. And I'll tell you why you got lucky in a bit. If the determinant is 1, the result is just the adjoint of the matrix. I'll tell you what that means in a bit. If the determinant isn't 1, or if I hadn't given you that information, if you don't have that observation, somebody did something in the past. When I gave you a question on multiplication on matrix, if you were the one, please identify yourself. I don't know who that is. The person did something like this. I'm looking for x, right? Somebody did something like, let x be a, b, c, d. Use this approach. I gave something like this. Were you the one? I gave a question. I told you, I gave you matrix B, I gave you maybe matrix A, then I asked you to find X. And somebody did let X be A, B, C, D, did the multiplication, formed the equation, and solved. Maybe you? I don't know who, but somebody did that. There was a question on product of matrix, and I had this kind of problem, and somebody used that technique. But anyways, so somebody who doesn't know some properties will use this technique. Without flipping, the flipping, whatever works because the determinant is 1. If the determinant wasn't 1, you wouldn't be able to flip like that. Okay? So I'm not going to go that route. So if my x is this unknown matrix, what can I do? I can find out my bx is equal to I to be something like this. So my b is 2, 1, 5, 3. My x is a, b, c, d. And the result will be 1, 0, 0, 1. Do you agree with this?
Yeah.
Everybody talk to me, please.
Yeah.
Okay. So with this, can you still see? Can't see that. Okay. Okay. So from here, is there a problem, ladies? No. Yes, no. Thank you. Okay. So now, if we multiply, what do we have from the first entry? If I take this away, what? 2a plus c. The other one here, 2b plus d, right? Right?
Yeah.
Please, I need response. And this is 5, this is 3. So what do we have next? 5a plus 3c and 5b plus 3d. And everything is 1, 0, 0, 1. So what does this tell you?
Simultaneous equation.
Simultaneous equation, 2a plus c equals 1, 5a plus 3c equals 0. Then another set of simultaneous equation, 2b plus d equals 0, 5b plus 3d equals 1. So you have two simultaneous equations to solve. This is a general way of solving this kind of problem. Okay? This is a general way of solving this kind of problem for now. Now, if you solve this, you agree we multiply this by 3, right?
Yeah.
So this will be 6a plus what? 3c equals 3. Then 5a plus 3c equals 0. And we're going to subtract, then you get a equals what? 3. So if a is 3, 2a plus c equals 1 becomes 2a plus 3 equals 1, right? So 2a is equal to negative 2.
I thought A is 3, not C.
Oh, okay. So a is 3, thank you. So that will be 6, right? So c is equal to negative 5. Do you agree?
Yeah.
So if we solve this also, we can also multiply this by 3. Then we get what? 6b. Is it the same?
Yeah.
Do we have the same equation?
Yeah.
So it's still safe to say that we get the same thing, right? So a is being replaced with b. So B will be 3 and D will be -5. Somebody get the dog, please. So if that is the case, why are you just coming in, Cherry? This is almost 20 minutes into my lesson. Why are you just coming in? Have you been in school? Are you just coming to school? All right, let's take a seat. Talk to me later. I don't like lateness in my class. 3 is A. Where's our B? B's over here. 3 also. -5, -5. That's a weird matrix. Are you sure about this?
I don't think it's correct.
I don't think so. This is 1, this is 0. So we can't have the same. Sorry. We can't have the same. Do you agree? Yeah. Even though the left-hand side is the same, that was a confusing thing, the right? Where are you leaving to again?
Getting a chair.
No, can you take this, please? I don't want anyone leaving again. Thank you. All right, so multiply. We have 6b plus 3d equals 0. Then this remains 5b plus 3d equals 1, right? So what happens? B equals -1. Right? So we put that back in here. 2b plus d equals 0. So this is -2 plus d equals 0. Then d is what? 2. So what is the matrix now? X is what now?
1, 0.
What?
3, -1.
Whatever you're writing in your book, let it remain in your book. Thank you. Yes? 3,
-1,
-5,
2.
I don't know where she got that 1, 0. You were not listening. You were busy writing. You're not following what I was doing on the board.
Do this right. You tell me to do it.
I didn't ask you to do anything. I asked everybody to pay attention. All right. Now this looks like some flipping whatever pattern. The only reason you have that is because the determinant of this is 1. That's how some of you did it. If this wasn't 1, 0, whatever, that investigation wouldn't have been useful to those of you who used that trick. Then you wouldn't have any choice but to rely on this technique for now. Okay? Now, we can't be doing this all the time. If we can have a relationship, if you multiply, look at this. Let's go to numbers. This is 3 over 4. Multiplied by something, you get 1. What is this?
4,
Really?
4,
Can I hear that louder, please?
4 over 3.
This will be 4 over 3. Now, what is the connection between 3 over 4 and 4 over 3?
It's flipped.
Flip is your own language. What do we call them mathematically? We don't call them flip. I've never had a flipping number. Come on, guys, this is Form 3. This is not grade 5. They're not babies, so don't give me baby languages. Yes, again. They're inverse to each other. What did I call 1 in multiplication? I've said it twice now. Identity. So when 2 inverses multiply, the result is always what? Identity. 2 matrices multiply to give you identity matrix tells you they are inverse to each other. The same thing happens if you perform XB, you must also get I. That's why somebody wrote as their comment, commute. Usually, multiplication is not commutative, isn't it? Talk to me. Is matrix multiplication commutative in general? Except in special cases. We talked about this special case yesterday. The case of A. Oh, we talked about AI, IA is equal to what? A. You still can't remember some of this stuff 24 hours ago. Come on, that's disappointing. How about A with 0 matrix, and 0 matrix with A gives you what?
0.
0. So this is another special case of commutativity. If XB equals BX equals I, then these X and B are inverse to each other. But rather than call it XB or BX, this is how we write it. B inverse will be the same as B inverse B. So -1 as a power implies inverse, just like indices. Remember this? Something like 3 to the power minus 1 is 1/3. You remember this? Indices?
Yeah.
So that's that. So when you have question where this is the relationship, you don't have to go through all this stress. All you have to do is find the inverse of B, because you know this must have been the inverse of B. Does this make sense? So the question is, how do we get the inverse of B? 2 steps are involved. One of the steps you already know from the previous lessons, called determinants. The other step involved is something new we call adjoint. We're making it simple for IGCSE. Adjoint is restricted to 2 by 2. You are so lucky. Okay? In higher level, you will be doing adjoint of 3 by 3. To find inverse, it's kind of interesting computation anyway. So I'm just going to write what adjoint looks like, and I will introduce it to inverse. Then we will see why some matrices will never have inverse. And you'll be the one to figure that out when I write the formula. What type of matrix cannot be invertible? Okay? So please write. What is it?
Zero matrix.
No. It's partially true. All right, quickly. So what comments can we get from here? Notes. Look at this formula now. So to find the inverse of a matrix, look up everyone. To find the inverse of a matrix, you do reciprocal of the determinant, 1 over the determinant times adjoint. Now that's why I started with adjoint. The adjoint of any matrix is such that you flip the element in the leading diagonal and you change the sign of the other two. That's it. You flip the element in the leading diagonal, you change the sign of the other two. That was the pattern you were looking at here. If you flip this, you get 3, 2, minus 5 and minus 1 here. And the determinant of this matrix is 1. So that's why the result is actually just the adjoint. Because 1 over 1 is 1, so it makes no difference. But if the determinant is 2 or 3, then the flipping will never work. That's why I said you were lucky, because the determinant is 1. Does this make sense? So, tell me, are all matrices invertible? Do you know what I mean by invertible? What does that mean?
Can be has an
As an inverse. Okay, so the question is, are all square matrices invertible? If yes, tell me why you think so. If no, tell me why you think so. Or maybe an example of what is not invertible. To discredit the statement, not all matrices are invertible. Who want to go first?
Only square matrix, right?
It has to be square matrix. No? Why?
Because if all the numbers are the same, when you invert it, it'll still be the same.
Yeah, but it still exists, right? Invertible means the inverse exists. It doesn't matter if the inverse. For example, if you invert I, you still get I. So it doesn't mean the inverse does not exist.
what about 0?
Zero matrix. Yes. Why do you think zero matrix are not invertible?
Because you can't make negative 0.
Well, negative 0 is 0. So what's the scenario? You leave it as 0, right? So what do you mean? So what happens to that? Can you speak louder? Can you hear what she's saying? That's the key. Yes, can you say that again?
The determinant of A is like 0 or like other value, then when divided by it makes like a recurring decimal or is math like.
What do you mean other value? You mean like if determinant is 3?
Like for example, if it's like 3 then it's like a recurring decimal, then how can you make?
Well, okay, so if the determinant is 3, I can have 1 over 3 with some numbers, A, B, C, D, and I could have A over 3, B over 3, C over 3, D over 3. It's not a crime. Nobody said
No, I mean,
you shouldn't write the fraction.
if the determinant is 0, then it cannot make it. 'Cause
So restrict your response to 0, not other value. Okay? If the determinant is 0, then we're going to have a problem. So what kind of matrix can we not invert?
with the
You're just repeating what she said. Some types of matrix cannot be inverted, are not invertible.
Matrices with determinant.
You are repeating the same statement. I need you to give me a technical a term that we use for those. Come on, quickly. Certain matrices are not invertible.
singular.
Singular, thank you. You don't remember what singular matrices are?
Singular means
Singular matrices are the ones with determinant 0. Remember yesterday's task? I asked you to find the value of x for which this matrix is singular. And what you did was to put the determinant is equal to 0 and you solve the equation. So if a matrix is singular, you cannot find the inverse. So usually to find inverse, the first thing is to find what? The determinant. Don't start with the adjoint. You might just be wasting your time. Once you find the determinant, you get 0, you stop there and you write a comment. The inverse does not exist since this matrix is singular. That's your response. Once you get determinant is equal to 0, oh, this is a singular matrix. As a result, the inverse does not exist. You stop there. But if you do not get the determinant to be 0, you proceed. Then you can find the adjoint, then you can multiply using this formula, and that gives you your inverse. Does this make sense? So we're going to do this same question now. With this relationship, do you agree the unknown x is the inverse of b?
yeah.
Do we all agree? The unknown x must be the inverse of b with this relationship. Talk to me, everybody.
Yeah.
So which means if you get this in an IGCSE paper, something like this, do not bother yourself solving this long equation. Just look at it, oh, x must be the inverse of b, then find the inverse of b, and that's your result. Does it make sense? But if the relation is bx equals a, and a is a different matrix given, x is not the inverse of b, please. Does it make sense? There is something we use at not to your level, so you don't have to worry about it. If somebody wants to think about it, please look up. If you want to solve ax equals b, and this a is invertible, it has to be invertible anyway. If I multiply inverse of a to both sides, look, I get ax equals b. No, put it here. I do not expect you to use this, but if anybody cares to, the equation is AX equals B. I give you A, I give you B. None of them is I. So which means you cannot use invertible technique. So I multiply by inverse of A, I get A inverse AX, A inverse B. Can you see that? Do you understand this?
Yeah.
I only multiply this to both sides. Can you see that? Now, what is A inverse A? I. Thank you. So this changes to IX equals A inverse B, right? Now, what is IX? Louder. X. So X is actually A inverse B.
Wow.
So if you want to solve this equation, find the inverse of A and pre-multiply with B. Pre-multiply means it comes first. Remember, is it guaranteed that this is the same as B A inverse?
No.
It's not, exactly. So it has to be pre-multiplied. Of course, you will use these techniques maybe from Form 5, Form 6, or never in high school. It might be in your university program. But you understand the reason behind it. Okay? So this is only if this is not I. If this is I, just go straight to your inverse. If this isn't I, and you don't want to go through this simultaneous equation jargons, this is a quick way to go about it. Any questions? So we're going to take the inverse of few matrices. Let's write a remark. If determinant of A is 0, then A inverse does not exist. What does that mean? That is, singular matrices have no inverses, are not invertible. Singular matrices are not invertible. So please take note of that. Thank you, Trudy, for recalling that. Singular matrices are not invertible. Okay, so quickly, let's find maybe 1 or 2 examples, and that's it. Okay, what did I say is the first thing to begin with? Determinants. Start with the determinant. Determinant of X is determinant of 3, 3, 1, 1. What is the determinant? 3 minus 3, what is that? So, I get the adjoint? It's not possible, so no need to work out the adjoint. Okay? This means X is singular, X is singular, and so not invertible. Okay? If you have maybe, you can try that later. Let's try X is 1, 2, 3, 4. If X is 1, 2, 3, 4, determinant of X will be determinant 1, 2, 3, 4. What is this? Everybody quickly, you can do this later. 4 minus 6, which is negative 2. So now that it's not 0, the next step is find the adjoint of X. Okay? So what will be adjoint of X? 4, negative 2. So I do 4, 1, then negative 2, negative 3. Okay? You change it. If this was negative 3, this would be plus 3. Maybe we do that because I don't want some people getting confused. Alright, so in that case it will be plus, right? Would this be plus? And this will be 10. So, X inverse, which is 1 over determinant of X. Can you see what I did? I'm writing my formula all through. That's how you can remember stuff. You write it always. 1, 2, negative 3, 4. Sometimes you can leave it in this form, and sometimes you put it in fraction. It's allowed. So 1 over 10, 2 over 10, minus 3 over 10, 4 over 10, which is 2 over 5. Does it make sense? You know this is scalar multiplication. So if 1 over 10 multiplies each element, you write the fraction involved. Or sometimes you can leave it in this form. Does it make sense? Any questions, please? The question? Alright, this is where we call it a day. I'm just going to write the fraction. 1 over 5, negative 3 over 10, 2 over 5. That's it. Please hold on, please hold on. We'll meet tomorrow morning.
Daniel, at the bottom one,
Yes,
Alex,
hang around.
2, 3, 1,